episode of 3-minute videos with Nathaniel. Today, we will now solve question 1B of MAT Oxford 2010. The reason why I didn't start at A for this one is because I find B has a really interesting answer, and besides, now it's the 88th video. 88 is the number of keys on a standard piano. So every episode from 88 up to 100, I'll give a special fact about each number. The question asks to find the sum of the first two n terms of the sequence. Now, if you graph the sequence out, first we'll graph the odd number terms. So we draw 1, 2, 4, 8. It just buckets up. And then we draw the other sequence, the even number terms. We will draw this. It goes to 0. Interesting, right? Besides, the odd numbers actually form what a sequence is what is called the wheat problem. You know, you start with a grain of rice on the chessboard, and then on the next square you have 2, the third square you have 4, the fourth square you have 8, and then you have a massive amount of rice on the 64th square. And the other descending sequence is prominent in what's called Xenos Paradox. So this Achilles and the tortoise, so the Achilles sits at the 0 meter mark, and the tortoise is given a 1 meter head start. While Achilles runs 1 meter, the tortoise runs half a meter, and Achilles runs half a meter, the tortoise runs a quarter of a meter, and so on. But anyway, back to the question. So when you add this 1 plus 2 plus 4 plus 8 plus ... and then you have n of these terms in the first 2n, so you end with 2 to the power of n. It has a rather beautiful formula, 2 to the power of n plus 1 minus 1. Now, since there are actually 2 to the power of n minus 1, since it starts with 1, so minus 1, and 2 to the power of n minus 1. By the way, if n is a prime and this number, this 2 to the power of n minus 1 is a prime, this is called a Mersenne prime. Let me write it down for you. And if you multiply 3 to the 2 to the power of n, and then you subtract 1, it's called a atomic prime. Let me write that again. I got interested in atomic primes because of its structure, and when you sub n to be 0, 1, 2, 3, 4, 6, or 7, the result is always a prime. Go on, try it after you watch this video. Now, what is 1 plus half plus 1 quarter plus 1 over 8 plus ... plus 1 over 2 to the power of n minus 1? Also has this really elegant answer, 2 minus 1 over 2 to the power n minus 1. If you write the last fraction as another index form, which my maths teacher calls positive index form, you write it as 1 minus n. Now, what is the sum of the first two n terms? Well, you sum this number and this number to get 2 to the power of n minus 1 plus 2 minus 2 to the power of 1 minus n equals to 2 to the power of n plus 1 minus 2 to the power of 1 minus n. So yeah, that's a very interesting sequence. By the way, you know one of the most famous estimates of the number of particles in the universe? Well, it relies on definitions of powers of 2, and this number is actually called the Eddington number. Now let me write down the Eddington number for you. You see why it's so beautiful? Well, if you wrote it as 136 times 2 to the power of 2 to the power of 2 to the power of 3, you'll see why. Look, 2, 2, 2, and then there's this 3 at the top. And look, 136. 136 is actually 2 cubed times 17. Isn't it spectacular? 2 cubed here, 2 cubed here. And it also has 17, my favorite 2-digit prime, which is a very, very interesting coincidence, I might say. By the way, I've made code names for all the numbers up to 360, and this 136 is actually called octotes, and it looks like this. Well, I always use it to remember triangular numbers. For example, I remember it as octote 10, 15, 21. I know, it's really funny. And besides, 136 is actually a really interesting triangular number because it's actually a less truncatable triangular number. And I don't know if it's the largest, but I think it is. Because if you cross out the 1, you have 36, which is a triangular, and you cross out the 3, it's also a 6. But the largest one is 666. Well, if you cross out the 6, then you have 66 as a triangular, and then you cross out this 6, it will become a 6. Bingo! You now have 2 less truncatable triangular numbers. I'm not sure if I'm the first one to discover this, but anyways, thank you and goodbye.